So this is the community managed natural farming in Andhra Pradesh. Andhra Pradesh is a state in India, southern part of India. And we have a population of 50 million. And then there are, it's still a very largely rural state. And we have 6 million farmer households and 2 million landless farm worker households. So our vision is that all of them should transit to natural farming, and hopefully by 2031, we should have enrolled everyone. So that is our dream plan. And but before we go to 2031, we should take stock of where we are. So we started this in 2016 with about 40,000 farmers. But I think what is important to note is that this builds on a women empowerment program which started 25 years ago in the year 2000, when we started organizing rural women into thrift and credit groups and build their federations. So there's a huge program, the foundation for what we are doing today, what we started in 2016, is basically based on more than 20 years of organizing rural women into thrift and credit groups, building their federations, federations of federations, converging government programs through the women's collectives, enabling them to access loans from banks, enabling them to pursue their livelihoods, and also building greater intra-household equity. So that is the foundation laid. And so when agriculture became, quite unprofitable for everyone, more risky, so then we looked at what are the alternatives. And we arrived at natural farming, or, farming without any chemicals, as a better alternative for the rural communities. And so this particular program, APCNF, started in the year 2016. We had enrolled 40,000 farmers in 700 villages. And today, that means last year, March 2023, we had taken this to 850,000 farmers, covering 27% villages, close to 4,000 villages, and then 4,000 hectares is under cultivation. This is, in transition. Out of this, around 270,000 farmers, about 140,000 hectares are completely chemical-free. What is important to note is that we do not give any incentive to farmers. We know there is a transition of 3 to 5 years, but we do not provide any cash incentives during transition, and nor do we assure any market premium after transition. So it has to be profitable on its own for this transition to really scale up. And in India, 86% of farmers are small and marginal farmers with 1 hectare per capita land. So when I say 4 years for transition, it means, they do some small portion, 1/4 of their portion first. Then if they're happy, they increase the area. So then they have more practices. So both area expands and the practices, number of practices that they are able to follow increases. So there's both deepening of the program by each farmer, and also expansion of the area. So this is the situation today, and we plan to reach to 1.2 million farmers this year. And this, I will not go into this, the same problem everywhere. Yeah, so this is what I just want to mention, that, even though farmers are suffering from climate change, at the same time, the way we are doing farming is also the biggest cause for climate change. And what is the problem with our farming? Our farming or is leading to deforestation, forest fires, then leading to loss of soil organic matter. Keeping lands fallow itself is a quite a uh, important factor in increasing the greenhouse gas emissions, excess irrigation, overgrazing, wind and water erosion. Water erosion is one of the most significant drivers of loss of soil organic matter. And then over the last 60 years, 70 years, is the use of synthetic biocides. So this is the dilemma basically, or irony you can say. Farmers are facing the brunt of the climate problem, climate emergency. At the same time, we are exacerbating climate emergency. So we are caught in a vicious cycle. So our idea is, can this be turned around? Can farming be the solution for the multiple emergencies, livelihoods, food security, health, and environment? So in natural farming, we are mimicking nature. And in nature, it is the power of photosynthesis which is critical. As you can see in the slide, the leaves are the ones which make the food. There is no other living being which can make food except plants, and plants having chloroplasts. So solar energy is trapped by these leaves, and they convert water and carbon dioxide into sugars. Photosynthesis process. But what many of you may not know, and kindly mute, there's a echo. Yeah. So what many of you may not know, at least I also didn't know till I started, that only 40% of the food made by the plant is stored in the shoot system. 30% is stored in the roots, and 30% is pushed into the soil as root exudates. And why is the plant pushing 30% food into the soil? And that is how nature has designed it. So please remember that all nutrients that plants require for thousands of years are available in the soil, in the air and water. So there is air inside the soil also. Good soil means 50% should be air. So the food that the plant is pushing into the soil is basically the feed for the bacteria, the fungi, and all other fauna in the soil. But these two are most important, bacteria and fungi, because they are the ones which are interacting with the root hair directly. So they take the food supplied by the plants, the root exudates, they multiply, and they then absorb or make bioavailable all the nutrients that are available in the soil. So every plant requires 30, 40, 60 nutrients, not just NPK. So they make, of course, they also make available NPK, nitrogen, phosphorus, potassium, but also another 30, 40 elements. So that means in nature, there is a beautiful cyclical process. Plants are feeding the soil first. And in return, the soil microbes are providing to the roots all the nutrients that a plant requires, all nutrients at the right time and in the right quantity. So in chemical agriculture, the basic belief was that with each crop, we are depleting the soil of nutrients. That means 1 acre of paddy rice means some 40 kilograms of nitrogen is taken away from the soil. And therefore, that has to come back through a synthetic route. Otherwise, you can't grow the second crop. So that is how urea started, the NPK system. So plants are taking away nutrients. Therefore, the nutrients have to be provided through a external route. So in the case of chemical agriculture, it was through synthetic chemicals. In the case of organic agriculture, because cow dung, farmyard manure, crop residue waste, they have such low levels of nitrogen. So it was believed, if you have 40 kilograms of urea bag, you may require 10 tons of farmyard manure. So the farmers were, in organic manure, the farmers bring in tons and tons of manure. 10 tons, 15 tons, 20 tons of manure per acre. Both are not required. So I'm saying something very important, that, you do not need even 1 gram of synthetic fertilizer or organic fertilizer. You do require the plants because they have to feed the soil. In turn, the microbes provide the nutrients to the plant. So the plant provides 95% or even more of what is required to bring the remaining nutrients for itself. We need about 5% in organic fertilizers, organic manures. If 10 tons were applied, we require less than 5%. So we need only 400 kilograms per acre of a biostimulant. So the organic input that we provide is not for providing nitrogen, phosphorus, or potassium. It is for triggering this beautiful world below the soil. So the root exudates are providing the food. The bioinoculum are messaging to the to the microbes in the soil and bringing them in touch with the plant. So this is a very important difference. I request you to internalize this, and if there are any doubts, we can discuss at the end of my presentation. And when we had so many delegations from at least 12, 13 countries of Africa, and when they realized this difference, they were very relieved. They said, we cannot think of practicing organic manures, organic agriculture, because how can small farmers bring 20 tons of manure? They'll require so much cattle, etc. So that is why natural farming is different from chemical agriculture and organic farming. So if you activate the soil biology, they then bring all the nutrients that you require. But activating soil biology has another very important feature, and that is the bacteria, the fungi, the centipedes, millipedes, the earthworms are also excellent engineers. So they create a soil structure, they increase the soil porosity, so therefore greater water holding is available. So that means the plants, through the root exudates, by interacting with the microbes and the micro and macrofauna, are impacting nutrient cycling and water cycling and carbon cycling. So Mother Nature has designed it to be simple. Through one action, we are triggering these 3 cycles. And if you can see in this photograph, because of loss of soil organic matter, most of the soil in India are highly non-porous, non-permeable. But you can see the photograph in the middle that there is, thanks to microbes and the food the plants are providing, there is soil aggregation. So if you see the picture on the right side, it shows the pores. So good quality soil means 50% by volume should be air. So if you have a good soil structure, then water infiltrates whenever it rains, and there's greater water holding because carbon is getting into the soil. And the third, which is very unique to Andhra Pradesh, which is a global breakthrough, and also the reason why 40 different countries have visited us till now, that we have demonstrated through natural farming, plants can actually harness water from air. I don't know how many of you are aware that water in the air in tropical countries is up to 50,000 parts per million. That means there are 10 rivers of water flying over our head at all times, 10 rivers of water. So crops grown under natural farming acquire the ability to harness this water. So that is what this means. So through natural farming, we have created another beautiful mechanism of water conservation and harnessing new water, which otherwise is not recognized as a source of irrigation. And that is the uniqueness of the Andhra Pradesh community managed natural farming. So now, very quickly, I just told you the science. We are not chemical agriculture. We are not organic farming. We are saying, if you follow these principles, you will achieve all your objectives. First and foremost is that the soil should always be covered. And you know why. If the plants are there and they are producing photosynthetes, then the microbes are being nurtured throughout the year. But the second one is also equally important, that the crops should be diverse crops, not monocrops. And trees should be included in the landscape. So I would say this 1 and 2, these two principles are at the heart of what we are doing. Then, of course, third is to keep the soil covered with crop residues, then minimize tillage, then farmers' own seeds to be used, integrating animals into farming, and role of biostimulants they are catalysts. They are not providing nutrition to the soil. They are providing a signaling mechanism for the microbes. So they are there to trigger soil biology. Then we have, natural products as botanical pesticides. One thing is very clear, no chemicals, no synthetic fertilizers, pesticides, weedicides, herbicides. So these are the 9 principles, and this is the basis for our different practices that we follow in the project. So this is crop diversity. This is microbial seed coating. I think I'll send you this presentation, and Swati and team will answer specific technical questions. This is microbial seed coating, which is very important for better germination and better establishment of the seedling. And this is a biostimulant. It's got a long name. So Ghana Jivamrita, made from cow dung, jaggery, pulses flour, cow urine, and handful of uncontaminated soil. So this soil amendment is used, after the last ploughing is done, just before seeds are sown. But we are now asking our farmers to modify the practice and use this for along with of the seed. It will have maximum impact then. So this is an important biostimulant for soil fertility. The second one is liquid biostimulant. This is used after the plant has germinated. This is the Drava Jivamrita. Similar composition, cow dung, cow urine, some jaggery, lentils flour. This is botanical pesticide. You can see some leaves there in front of the trainer. Some of them are custard apple leaves. Some of them are neem leaves. So this is soaked in cow urine, and then it is extracted. Then this is a very unique phenomenon which we have developed, that is to do seed pelletization, so that we can sow in dry conditions. And that's why I asked John, whether your county receives good rainfall. So you receive very good rainfall. So what the pelletization will do will enable you to streamline the operations. What do we take after the main crop? What do we take after that? So this is a very clever, very intelligent way of managing the field, especially during this weather emergencies, drought or floods. And it's very simple. Women can do it themselves. Of course, if they are big farmers, they can use the cement mixers also. Then there are a lot of people who have doubts, what happens to the yields. So I can assure you, there's no yield penalty. This is data of, every year we conduct 2 independent surveys. So this year also the Kharif and Rabi have been completed for previous year. We'll be getting the report shortly. But as you can see, yield increase is there in all the crops except for one crop, except chilies. Then the savings, are, if you take the gross minus paid out cost, so you have net income, which is very significant. 45,000 rupees per acre is not a joke. So it is very clear that, this yield penalty is a myth, and in reality, natural farming does not lead to any yield decline. Same in the second result, we have tremendous increase in biodiversity. Then this resilience to floods. Since you have heavy rainfall, you have hillocks, so natural farming is even more important for you to withstand these spells. Early December, we had a very heavy cyclone Michong. Hundreds of thousands of acres of paddy, which was ready to be harvested, has been submerged now. But natural farming fields are intact. Their neighbors have suffered all the damage. So the resilience to floods is very high. Similarly, we did a study to look at water saving, and we find that this is saving water by 50%, which is not a small thing, up to 50%. Then, and these are major crops. Then we have drought resilience examples, and this is something we are taking up very seriously, because a large area in our state is semi-arid, and farmers are dependent only on one rainfall. Resilience to pest attack. This is our scheme for the homeless poor, so they are able to take these food gardens in their own actual home gardens. Then I'll skip all this just to say that through natural farming, we discovered a new phenomenon, and that is the plants, require less water, but more important, these plants grown through natural farming are able to harness water from the air. And you can see in the photograph, Walter Yenna, he is the one who has inspired us. He is based in Australia. Then starting with 11 farmers, we took this pre-monsoon dry sowing to 600,000 farmers last year. So on top of that, in a semi-arid area, we are looking at how can farmers get some more incomes. And they have come out with a cropping calendar in a please remember, this is for rain-fed villages also. So there is a window which is called the pre-monsoon dry sowing window. There is a Kharif window, Rabi window. So each crop has fixed up. For each type of soil, depending on the crops, we fix up a calendar. Throughout the year, we must take crops. And this is doing 2 things. One, it's keeping the soil covered. And then since they're diverse crops, it's very good for soil biology. Most important, it's good for the farmers' incomes. So this is just one farmer who practices this in 1 acre of a dry red soil. And she's a vegetable grower. But even in vegetables, there are certain things which will take more time. So we have to provide for that. Now, this is something very important, interesting for all of you. There are about, on this side, 13, 14 crops. So farmer is getting income from every crop. So the risk minimization on account of this is enormous. The case studies of farmers, cotton farmer. So as you can see, what we call as A-grade cotton model, cotton, field bean, cowpea, vegetables, bajra, and cluster bean. Plus about 20 varieties of biodiversity crops like millets, oil seeds, vegetables will also be broadcast along with that. And the market committee, wherever there is something to be sold, mostly it is for their own consumption, but they also have access for marketing. This is a drought-proofing model we initiated this year. No ploughing, but just digging this pit, which is a very shallow pit, and then planting the seeds there. This is actual work, pelletization work. Then there's a drought-proofing model. This is something we tried this year. So as you can see, we have achieved scale. Whichever village we go, we tell the farmers, we'll be in this village till everyone has transformed. It's not, you go to one village and put a tick and then go to another village next year. But without focusing on what happened in the first village. So we are not working like that. We are saying that every farmer in a village should change. So I call these 6 as the levers of how the program got scaled up. Of course, impact is most important. But in addition, to take it forward, government support, financial resources have been very critical. Then knowledge about the crop geometry, package of practices, inspirational stories. So we have videos of all that. We also have partnership with research institutions where they can help in the innovative farming that government is trying somewhere else. The third is very, very important, social capital. That means the women's self-help groups and their federations. They have held this project and helped it to, gain more and more stature, human resources, because this is the foundation. Then the fourth pillar is our extension pillar. That means farmer to farmer extension is the key. And we do not believe that somebody who is good in theory, has read some things, will be able to be effective in bringing about behavior change. So we pick up people who may not be very literate, but have practiced it themselves to make the change. And if they pass all the protocol tests, they can teach in the academy. So the first batch has just started. So as I mentioned, 200,000 women self-help groups are and 7,550 federations, village level federations. Then I mentioned about farmer heroes. Within in 50 cents, they're going to earn about 25,000 rupees per month. Then we do ICT. Yeah, this is a very important slide in illustrating our principles, that we fully agree that the choice of the transition is that of the farmer. But for the farmer should understand why this area is good or bad. And essentially because first year and second year, they will not be doing much of, it's more like a trial and error. Year one, the farmer tries, there's opposition within the household. So year one, more or less, is a struggle in convincing the family members. And many cases, the wife and husband divide the land into 2. And generally, it is the wife who is practicing natural farming, husband who is practicing conventional agriculture. But by year two, their knowledge improves, quality of the soil changes. So we believe that every farmer needs 3, 4, 5 years of hand-holding support. At the same time, every village requires a dedicated team in that village who will continue regardless. So there is what happens to farmers in year 3 and then years 8. So there is a gradual movement. Each village also, not everybody will come in the first year. So based on the success of their neighbors, they also start committing area for natural farming. So please keep this in mind, that if we go to a village, we should be prepared for the long haul and not be satisfied in just introducing the program and coming out of the village. Of course, we have other interventions also, marketing and health and nutrition. I'll not go into that. Then right from the beginning, we decided that we should have collaborations with a range of international, global institutions working in agroecology and also national resource organizations. Let me also confess that national research organizations were a little slow, late in coming to work with us. Then we set up our own academy, and there's also one very important platform for India and Kenya to start. You can actually send your young farmers here for 6 months, 1 year, and then they can go back and practice this. So this academy is meant for several things, but I just want to talk about farmer scientists. So we have decided that one per village will be selected as a farmer scientist and groomed for 4 years, 1 week in a month classroom, 3 to 4 weeks in the field, so that they are thorough. They also understand the why, they also understand the how. And this is very, very close to us. Then we are supporting other states in India and we are supporting other countries. This is the last slide, which shows why green cover will reduce the latent heat in the air and which will result in cooler airs coming to our side of the ocean. Yeah, so I just complete now because this is a very important saying from America, one of the native American Indians, very wise people. They said, we do not inherit the earth from our ancestors, we borrow it from our children. So the question is, the earth that we have borrowed, how are we going to return it back to our children? I just want to conclude. I also want to say, John, that through our methods, we are finding that young farmers are more interested in staying back in agriculture than going to the cities. Small number, and some even smaller number are coming back to the villages. And we are assuring them, if you do this properly, you should earn as much in your own village as you're earning in the city. You should also have income throughout there. And your fields, your crops should be resilient to floods. We had the cyclone